Hello and welcome again as we consider yet another multiple choice question for IB chemistry. The electronegativity values of four elements are given: carbon, nitrogen, oxygen, and fluorine. What is the order of increasing polarity of bonds in the following compounds? Well, the term electronegativity is underlined here, and you need to understand what electronegativity is first of all, and then be able to relate that to the polarity of covalent bonds. Electronegativity is a term that refers to the relative attraction for electrons that are shared in a covalent bond. So if you have carbon and hydrogen engaging in a covalent bond, and carbon is given 2.6, and hydrogen, not given here, but has an electronegativity of 2.2, then the difference in these electronegativity values is 0.4. And you don't have a very polar bond in such a case. But if you do happen to have, instead of hydrogen here, oxygen, which has an electronegativity value of 3.4, then this difference in electronegativity would come to 0.8. Now this difference in electronegativity is what gives rise to polarity, because if the electrons which are shared here in the covalent bond, carbon and oxygen, if these electrons are held a little bit more closer to oxygen than they are to carbon, then the oxygen atom is going to acquire a small negative charge, and the carbon atom would acquire a small positive charge. So this difference in electronegativity is what gives rise to polarity. And you should remember that electronegativity refers to this relative attraction for the electrons in a shared covalent bond. There are no units. Fluorine is the most electronegative element in the periodic table, and it's assigned a value of 4. And that's closely followed by atoms like oxygen and nitrogen. So these are three very electronegative elements here, and carbon, which is not as electronegative, included. So what you have to do then is to try to arrange these possible answers in order of increasing polarity. And to get this increasing polarity, what you're doing is finding which combinations would give you the maximum electronegativity difference. When you get a big electronegativity difference, that is a sign that you have significant polarity. Now, because the time in the exams to complete these questions is limited to about 90 seconds per question on average, then it's important to find the shortest route to the answer. So, seeing that you need to arrange these in order of increasing polarity, it means that these final structures here in each of the answers should have the maximum polarity, and these should have the minimum. So you should begin by seeing if this first one is greater than this, and there should be a big difference here. Let's start from the first one, CF4. Now we don't need to bother about the 4. We're just looking at the carbon and the fluorine. The difference here, 4 minus 2.6, is 1.4. This is 0.8, carbon and oxygen. Then nitrogen and oxygen, 0.4. So increasing order of polarity? No, because you have 0.8 all the way down here and 0.4 here. So we can eliminate this. Here we have carbon and fluorine all the way down here. And then we have this with 0.8 CO, so we can eliminate this. Here we have carbon and fluorine all the way up here, which is 1.4. Then we have down at the end nitrogen and oxygen, which is 0.4. We already worked out carbon and oxygen, which is 0.8. And OF2, oxygen and fluorine, which will be 0.6. The question is, which is the order of increasing polarity of bonds in the following compounds? Greatest polarity because of the greatest electronegativity difference, then this, and then this. So it immediately suggests that the answer is C, but you can quickly eliminate D also. CF4, of course, is 1.4, so you can quickly eliminate that, just like you eliminated B. So the answer to this question, C.